Assalamualaikum and very good morning to all of you. Right now, I would like to cover topics number 5, which is under for power efficiencies and management. And if you think properly, why you have to consider the farm efficiency at the beginning of the semester, I'm already a brief um, in terms of the most influence factor, the most significant factors in terms of the field operation for the machinery, which is actually considered as efficiency factors. Um, in order to consider the factors for efficiency, there are two parameters that need to be concerned of. One is machinery, which is the parameters of machinery, which is first of all the width of the implements, which is going to cover for different capacity of the machinery. Secondly is the efficiency of the implements. And the second factors is the time factors, which is the time for turning, transfer the load or yield, and the time for the operator spending in the field. So both the time here is the main factors that going to be considered in the field farm efficiency calculations. So from here, from the picture, you see that if the operator resting down on the farm, and this is not going to be calculated as one of the parameters during the farm machinery efficiency calculation, and as well as during the machine breakdown is considered total loss. So then basically there is no such operation on that particular day. So we consider there is no farm efficiency in that particular operation. And down below we have a photo of the field operation, the pattern of harvesting, and as well as for the tillage practice. And if you imagine, like considering the large acreage of this area, so you can see that there is a vast area for the operation of the tillage or land preparation as well as for the planting. You can see that there is a huge turning area which is have to take from machinery. So in this case, when machine doing the turning is considered the time lost during the operation. And when the machine doing turning also is not counted in the farm machinery efficiency calculations. Alright, in terms of the farm machinery operation, so like I said, the width and the speed is one of the two parameters that need to be considered during the operations. So the width, for example, the combine is the width of the teeth of the cutter bar. Sometimes we call it effective width, which is not the actual width of the cutter bar. The effective width is the width of the crop that enter the combine harvester, which is going to be different in actual width. Secondly, the parameter that we would like to measure is the speed of the track of the combine harvester while running the operation. So please remember that. Alright, how to evaluate the machine performance in the field? There are three types of parameters that we going to cover. First of all, the performance which can be related for each machinery that can complete the field job, which is the method in determining the cost per hectare for that operation. So the outcome of this capacity is should be able to estimate the cost of operation as well as the time spent for the such operation. And in the big pictures, why you need to have information of the TFC, EFC, or field efficiency as overall, other than the cost, is on the different management. Let's say you have many tractors, let's say 10 tractors. So one of the particular information that you need to know how long one particular tractor could finish in one particular area. So meaning that you will have better managed in terms of the labor costs as well as the overall field machinery management for that particular operation. Alright, now we are going to cover one by one what is the TFC, EFC, and also FE, field efficiency. Right, TFC, or stand for theoretical field capacity, is a theoretical rate for the efficiency, which is based on the field coverage that will be obtained if the machine operates at 100% functional well at a rated forward speed and always cover 100% of its width. For example, if you have a combine harvester, theoretically you can say that let's say 5 meter width of the area will be fully utilized under that particular cutter bar. So will be 100%. That will be considered of TFC with the condition that operate at certain speed. And while the effective field capacity is the actual average rate of coverage by the machine based upon the total field time. So this one will take into account the time loss during the field efficiency calculation, as well as the based on the average rates of coverage by the machine. And lastly, we have the FE, field efficiency, is the ratio between the two, between the TFC and EFC. Of course, the TFC will be higher than EFC. So if you take the ratio between EFC over TFC, so you can express in percentage. The theoretical time per acre or hectare is the time required by theoretical field capacity, which is the corresponding unit. And the effective operating time is the time duration when the machine actually operates. So if we consider the most effective time, it should be reflect to the machine that actually operates. It is more than theoretical time if the width of operation is less than the actual width of the machine. That means that if the theoretical say that we utilize 5 meters width, so not necessarily 5 meters, sometimes the width of operation will be less because of the crop distance will be, is less. So it will turn out will be different of the effective operation operating time as well as we reflect to the effective field capacity. Right. If you follow, this is the formula of the TFC. So TFC in the unit of hectare per hour, equivalent to speed in kilometer per hour, must be in this particular unit. Time width of the implement, let's say combined just now I give you 5 meters over 10. 10 is a constant number, so you can just divide by 10. In this case, I give you one of the example. At the variable speed, you can have different TFC according to different swath width. If you take example, let's say the swath width, meaning that the width of the machine or cutting bar machine, let's say 20 meters. So at 12 kilometer, if you're running at 12 kilometer, you will get this TFC value. Let's say if you want to run for up to 20 kilometers, so the value will be higher. So about 4%. Okay. Well, sorry, about 0.04 hectare per hour. That would be the capacity for this particular example. Alright. Theoretical field capacity is calculated as follows. So W is the width. So this is explained the formula as from before. Okay, I'll go through. Next on EFC is the machine or implement EFC efficiency that can be calculated from following formula, which is W. V times W, V stands for speed, W for width, and FE is the efficiency of particular machine or of the particular implement over time. Right. EFC is the relationship between the width of the implement or machine, percent width actually used, speed, and time loss in the field during operation. It is impossible to use maximum implement width for those implements such as harrow, tillage implement, grass cutter, and combine harvester without occasional miss. So sometimes when we do actual operation, so we experience a missing or overlap. So that would be not take into account in the effective field capacity calculation. So meaning that in this case we have to adjust the time that's spent on that particular overlap or as well as the missing location. And the overlap normally occur when there is no marking on the soil. And overlap is also a function of speed, ground condition, and also operator's expertise. Some of situation, some of the crop yield is abundant. For example, the combine harvester. So you cannot technically cannot maximize 100% because we will cause the clog in the header as well as in the process. So we normally go up to at most about 75% of the optimal cutting width. Right. Machine means for row crop use 100% of heat width compared to machine implement for the field. Okay, so for machine for the row crop, for example, for the combine harvester, the width normally 100%. However, the feeding rate will be a bit slower, not too fast, in order to cater the process in the combine in the harvester. However, for the row crop, for the line preparation or field operation, it will be less in terms of the usage of the width. Open field implement cannot avoid overlapping field with, for example, the rotary tiller. So this with this, some of the operation might have some overlap. All right. The width of the implement with multiple unit is calculated by multiplying the width of space between unit with the number of the unit, so that the space next to the end unit are covered. So in this case, if you have multiple units connect to the behind the tractor, so the width should be uh, so calculate the total width. So easily you can calculate one width of one particular unit times the number of the unit, so that the space between next to the end are covered. Alright, so for example, this one is a mobile plow. So in this case, the coverage area will be less, and in between you can see that there will be no coverage of the particular area. That's how we calculate. The width should be one to one and measurement. Maximum speed possible is subjected to the factors such as the type of condition of the field as well as the engine power. Normally, on a rule of thumb, the speed of the operation for the field operation is about between 5 to 8 kilometers per hour. For the combine harvester, is also about the same, about 5 to 10 technically, but nowadays people want to reduce their losses from the combine harvester. So we often go for less than 10, about maybe from 3 to 5 or 3 to 7 kilometer per hour, which is better in terms of the uh, yield loss. But there is no significant effect on the total return of the income of the farmers. Right. The total loss is variable that is difficult to quantify in the estimation of the field capacity. The field time may be lost due to adjusting of the machine or during parts lubrication, breakdown, clogging, turning at the end of the field, refilling, seed, fertilizer, unloading, and waiting, etc. So this will be considered as a time loss during the operation. Okay, the time loss is not counted when machine is ready before beginning of the fieldwork. So this means that sebelum kamu buat kerja di ladang, so kamu dah prepare tractor. So meaning that the time that you spend for the work preparation is not counted in the field, field efficiency calculation. And also, excuse me, and also during the lost time due to major breakdown. So only minor breakdown is considered is okay for the field capacity calculation, and some of the operation require daily or daily services. So for example, combine some of the belting problems, so that will be considered as minor breakdown. So the time required to do some minor maintenance will be counted as total loss. The time required to travel from to and from the field is accounted for the total operation cost, but it is not considered to be calculating of the EFC or field efficiency of the machinery, since the field capacity or FC do not depend on the location of machinery owner. Alright, so I hope it's clear. Alright, the common value of the farm efficiency implement. For example, if you have more tillage operation, for example, plowing, disking, and cultivating, So the range between 75 to 90%. Seeding, uh, with or and fertilizer for the grains or for the crop between 45 to 80%. With seeding and fertilizing for row crop counted at the lowest, about 45%. So why? You might want to think about this because the operator has to stop frequently to refill the grains, refill the seed, as well as to refill the fertilizer. So that's why the farm efficiency, uh, uh, so field efficiency of the machinery is less. However, the highest is of course the tillage operation, which is not required to stop. The combine harvester is between 65 to 80%, and the field chopping for the grass, for the gray, for the hay, or for the pasture operation, so about 50 to 75%, and spraying about 55 to 60%. Alright, the time loss during turning. So just now, remember the photo that I mentioned, the tillage operation. When there is a turn, meaning that the tractor or the overall operation for that particular day will be considered as a loss. So the turn at the end of the corner of the field represent the loss of time. That is often to considerable importance, especially for the short field. So in this case, you have to be strategically consider uh, the shortest time spent for the cornering, meaning that if you have a square, so pretty much you cannot avoid. If you have the longer section of the field, so you might want to consider to choose that particular field, particular point to start with the work in order to um, reduce the turning, or which is considered as a time loss. Regardless of whether the field is worked back or forth for work by traveling around the parameter, the total numbers of turns per unit area with the given width of the implement is inversely proportional to the length of the field. So meaning that um, if you have a um, rectangular field, so pretty much you're going to have a um, less number of turns per unit area as considered to the um, perfect square field. Alright. Um, if only field efficiency is required, it can be estimated by taking total time in the field for an extended period, or like say a day. Average speed while the implement is working, total area covered, and the width of the implement. The average rate covered can be related to PFC in order to determine the FE. Alright. This is in order to um, calculate the time loss. So field machinery index, or FMI, is one of the parameters that we take into account. So from field machinery index, FMI, which is considered as total field time. Let's say you operate the combine for 1 hectare area, and total time spent for harvesting, let's say 1 hour or 60 minutes. And then you have to minus total stop time or reverse, and minus also total turning times. Okay, this is operation by the combined harvester. And then over total field time minus total stop time or reverse. So the total turning time will be your losses during operation, and then times 100 in percentage. Alright, if you plot the turning time, in this example, it shows the FMI will increase as in the reduction of the turning time, meaning that if you have less time during the turning, meaning that your machine is actually quite efficient in doing the uh, the operation, harvesting operation. The estimation of the speed and FC. The estimated value is sometimes useful in the field or the lab. The estimation can be made by walking at the pace with the implement. So in this case, I give you some information of how you want to estimate the speed of some of the tractor, also combine harvester. So other than this, you can also set the distance and then set the time by conventional method using the measure tape measure, as well as the time. So from there you can estimate what is the the speed, average speed. Alright, the FE, field efficiency at 83% is normally for tillage operation. This mainly can use in this formula if the speed and implement width is known. So for improving the FE, presently for field machinery become more complex and more expensive, it is important to get maximum output from the machine. Reduction of time loss is one of the methods in increase the FE. So in order to increase the FE, you have to reduce the time loss spent during the turning, for example, as well as other losses. Development of the implement that are more efficient in the system of material management within body of the combine harvester have been a potential in increasing the FE. Right. However, in for the seed and fertilizer and weedicide operation, we cannot get too much because some of the operation need to be transported from one location to another, so it will reduce some of the FE. And as well as for handling of the material in bags may consume up to 20% of the total time in the field during planting operation. Alright, and as a summary, this is the formula for the TFC, EFC, and FE, and basically the summary of the formula on this topic. Alright, as an exercise, combined having 2 meters cutter bar is operated at speed of 4.5 kilometers to harvest wheat crop, in this case wheat, gandum. If 10% lag time is lost in turning, loading and unloading, calculate the harvested area in 8 hours. So we want to calculate how large the area can be completed in 8 hours, considering with 20% time loss. So time loss there can be from the turning, can be from the stop, or anything. Okay, so meaning that you have another 80%, which is counted the actual field capacity of the combine harvester. Right. So the solution is given here. I would like you to try and then go on with the solution. Alright, exercise number 2, calculate the theoretical field capacity, effective field capacity, and also field efficiency of 4.5 meter range combine harvester, which is the width of the combine harvester, operating at forward speed of 5 km per hour. The average width of cut is 3.5, and time required for emptying the grain tank is average to 20 minutes per hectare. So turning, adjusting, and other miscellaneous time requirement accounted for 50% of the effective operating time. So a bit critical here, you need to understand very carefully. However, the answer is here. So it will be good for you maybe to try a few exercise and then after that try to calculate the numbers. Alright, exercise number 3 on FMI. So go ahead and try this, and pretty much straightforward. I hope you're able to see that. Alright, there will be assignment number 1 on Blast, as well as from lecture notes. So I will post it